get started. Good morning, or again, good afternoon, everybody, depending on where you are. Welcome to the All Things Patch webinar. We're really excited to have you here today and to dive deep into the Patch Manager feature within AWS. Before we jump in, I just wanted to let you know that if you do have any questions as we go through any of the slides or the labs today, feel free to add them in the chat. We have a handful of our technical experts who are on the call today, so we will make sure that someone gets your question answered for you. So again, if you have any questions, feel free to go ahead and just pop those in the chat there. So for today's presentation, our team of technical experts here at AWS will be walking you through an overview of both sort of cloud operations at AWS to give you some helpful background context. And then most importantly, we'll be doing that deep dive on Patch Manager today. You'll get a chance to try out Patch Manager yourself during the hands-on lab. So you'll get a chance to try some of the cool things that you'll hear our team of experts chat about today. My name is Megan McCluskey. I'm a Senior Customer Solutions Manager on our worldwide public sector team based in New York City. And I'm going to go ahead and be kicking it off today. Okay. So before we jump in, I just want to go over a brief agenda just to set the stage of what you'll be learning about today. So first, we'll kind of go over what really makes patching hard. This is really the foundation of what we had in mind when we were building out the features within Patch Manager. So we'll kind of talk about that and set the stage for what the Patch Manager can solve for you and for your teams. We'll talk about how AWS Cloud Operations can help, just kind of giving you some background context and our philosophy around Cloud Ops, giving you some helpful context around other Cloud Ops services and features, and just making sure that you're walking away with an understanding of how we run centralized operations management and Cloud Ops here at AWS. We'll talk about registering those managed instances so we can talk about how you'll actually be able to leverage all the features of Patch Manager. We'll go over how you can enable patch management across your AWS organization. We'll talk about some advanced patching scenarios just so you can understand some more advanced scenarios and how you could possibly leverage those as well. And then lastly, we'll get into the workshop where you all can really get your hands dirty and get into our Patch Manager features and functionalities yourselves. So before we jump in, I want to just kind of go over a scenario that hopefully isn't too common, but some of you may have been in before. So let's say it's 3 a.m. and you've been paged because of a suspected data breach. You respond to that page, and sure enough, it looks like the personal data of thousands of your customers has unfortunately been exposed. Your company's customers are in an uproar, understandably, and the company's engineering and security teams are scrambling to understand the full extent of the breach and how it came to pass. And it turns out, when you did some digging, that vulnerability that attackers had exposed to access the data was a commonly used piece of application software. And as that investigation continues, it turns out that this vulnerability was disclosed some time back. And to make matters worse, there was well-documented steps issued by the vendor of this piece of software, which, when followed, could address the root cause of this vulnerability. Now, this is not a pleasant situation for anybody, especially for those customers that had their data exposed as a result of this data breach. But the question that remains is, why wasn't it addressed if the steps to address this vulnerability had been out for some time? Why wasn't this vulnerability patched? Now, there are many reasons why companies, both large and small, struggle when it comes to establishing and maintaining that patch management strategy. Let's look at some of the common challenges outlined by NIST, or the National Institute of Standards and Technologies, which often faced by organizations when it comes to implementing an overall patch management strategy. So what makes patching hard? To start with, patch management is dependent on having a current and complete inventory of the patchable software, including applications and operating systems that's installed on each host within the company's environment. Secondly, enterprise patch management can cause some resources to be overloaded in terms of both people and infrastructure. So for example, you might end up with many hosts trying to download the same large patch at the same time. Next, installing patches can cause side effects to occur. Another common challenge, which often causes organizations to err on the side of caution, is unintended or unexpected problems that are caused by patching. Now, it can be surprisingly difficult to examine a host and determine whether or not a particular patch has actually taken effect. This challenge could be faced on a single system Or if you extrapolate that out across an entire organization, fleet, or servers and operating systems, the scale of that challenge can quickly become very overwhelming. So let's see where an operating journey at cloud scale should look like. So customers have asked us for a way to manage patching and compliance across their organization and control patching on both cloud and on-premise environments. That could support multi-platform from Linux instances and also edge devices using IoT Greengrass, and moreover to control and define their own patching parameters and schedules that make sense for their business. So using that scenario that I just discussed, let's see what this administrator could have done in order to prevent this situation and to address those common challenges for a patch management strategy. So how do we make things better? What are some of the ways and the things that we can do to help address some of those common challenges organizations face when it comes to patch management and avoid a scenario like we just discussed? It really comes down to three things: prioritize, classify, and scan. You want to make sure that you have your classification of workloads, prioritization of patches, your creation of those patch baselines. You want to execute scanning, and you'll execute patch deployment using all sorts of steps and all sorts of documentation. Now, going through these steps manually, it is not scalable. And that is not necessarily a great use of your time. We want to make sure that you all have time to innovate and make things better in your organizations. So how do we make things better? How do we make this process less manual, more effective, more automated so that you can get that time back and continue to innovate? Again, you want to prioritize, classify, scan, and patch. The prioritization of patches. You have a small set of patches that you must prioritize. How do we go about doing this? They're the classifications of what functions are most critical to your business, and then which patches make the most difference to those functions. You have email, customer-facing digital properties, and more. And from there, we can create what we call patch baselines, which are collections of patches. Now we can go ahead and commence scanning. This will help us determine our level of compliance against the baselines that we've established. And at this point, we move to the actual patching in an ordered, business relevant order that makes the most sense for your business. Again, doing all of this manually, not scalable, not necessarily the best use of your time. For large organizations, having automation in progress is key. As those organizations grow in size, AWS Cloud and our tools to support with centralized operations management will help provide the tools that help you automate and scale. Automation helps to ensure that your teams can spend time innovating and optimize as opposed to spending that time doing manual tasks. So we've talked about centralized operations management, we've talked about automation, we've talked about cloud operations. How do we actually enable this? So while AWS Systems Manager is the primary service that we'll discuss, the real power comes from how it integrates with other AWS services. It's important to note that most of the capabilities we'll talk about here can be implemented individually, but the value increases the more that you leverage. Many customers are familiar with our node management tools like Patch Manager, Session Manager, but there are some other newer capabilities as well. So multiple environments historically require multiple tools, which further complicates training your staff, operations, security, and compliance processes. AWS lets you automate operations processes across your environment with agent-based management that works on AWS, on-prem, edge, IoT, and even other cloud providers. We integrate data for resource configuration, observability, and compliance, and other event data from sources such as AWS Config, CloudWatch, CloudTrail, and EventBridge for a consolidated lens to the state of your resources. Automating frequent high risk or compliance related activities is the key to scaling while also maintaining security, improving your resiliency, and also reducing risk. Manual processes simply don't scale, and again, they're simply not the best use of your time. Some examples of this include automating your patching, like we discussed, maybe updating out of compliance resources, and I'm sure you can think of many, many more. AWS has over 300 predefined automation documents or runbooks that you can use and customize for your environment, or you can even build your own. It's going to reduce that time to resolution. It's going to reduce the manual effort and the associated risk of error that comes from that manual effort. It's also going to reduce cost and compliance gaps. It's going to improve your security posture by reducing individual access to underlying infrastructure. You'll have a delegated admin for those pre-approved runbooks. Remember, designing with operations in mind. Automate early. It should not be an afterthought. It should be integral to everything that you do. So these automations can be triggered by any of your operations processes. Service catalog allow you to request any fulfillment. Your change management will let you define change templates and either automatically or manually approve them as your org's processes require and trigger automated execution at a predefined time. Event management lets you identify issues, launch automations to resolve, triggering a change management operation, or even executing break glass actions such as launching a session. Incident management is going to help you define incident response plans for mission-critical applications, notifying responders, providing relevant underlying resource data for troubleshooting, collaborating through AWS chatbot, and resolving incidents through automation or break glass processes. Finally, it provides a RC data and recommended next steps, including problem management for any recurring incidents. If you're using an ITSM solution, such as ServiceNow or Jira Service Desk, the AWS Service Management connector gives you bi-directional integration, eliminating manual processes and data entry. Your system of record can now directly trigger actions and collect data verifying that those actions were taken along with the outcome. These processes and automations can be performed at a resource level or in the context of an application or workload as defined by the AWS Service Catalog App Registry resource groups, or tagging, which lets DevOps teams focus on relevant resources to their workloads. And critically, all of this helps you enable compliance. Traditionally, service management and compliance processes are managed by a workflow solution which relies on manual execution. Then, as a compliance cycle ends and you start to prepare for the audit, ops teams have to manually collect data to validate things like change approvals and logs, user access and action logs, and if an anomaly is found in the audit process, searching through email chains, meeting minutes, and thought could be hundreds of other documents just to find the cause. Again, not a great use of anyone's time. Compliance data such as state of resources, alerts and alarms, compliance rule statuses, actions performed by who and by when is all collected through AWS Config and Systems Manager, and they can be accessed holistically through AWS Audit Manager. And the amazing thing about the AWS Cloud is we can really handle the scale of automation that we just talked about. I want to give some quick stats on the level of scale that we're handling today, just to give you a better understanding. Amazon CloudWatch handles a mind-boggling 11 quadrillion metric observations a month. Breaking that down, that's 11,000 trillion, 15 zeros, 4.2 billion per second. So that is 15 trillion in the hour that we give this talk. Pretty crazy to think about. AWS Config performs about 9 billion configuration and compliance checks every single month. AWS Systems Manager manages more than 20 million instances every single week. And for AWS CloudTrail, in this next hour is going to be busy processing 35.4 billion, that's billion with a B, API event audits. Just wanted to give you some understanding for when we say we can handle this automation at scale, you really get an understanding of what we mean by that. So we've mentioned Systems Manager a couple of times in this presentation, and Systems Manager is a powerful service with a breadth of features and capabilities. We've categorized these features into IT service management, application management, and node management. Many of these features can work independently of each other, letting you adopt Systems Manager for the use cases that make the most sense for your business first. First, Quick Setup helps you set up Systems Manager's features easily for many use cases, such as scanning instances for missing patches, configuring collection of inventory, creating and configuring IAM profile roles needed, and many, many more. Automation. This is a word we've mentioned often, but again, it's so important. Automation is a key feature of Systems Manager, which is helping you scale consistently and easily. It works across Systems Manager's capabilities, letting you eliminate manual errors in your environment by authoring repeatable runbooks triggered by event bridge rules, maintenance windows, state manager associations, change manager, and more. Systems Manager IT service management features work in concert with other AWS services, leveraging automation to help bring visibility to and automate resolution of any issues that you may have. They can work independently, or if you have an ITSM solution such as ServiceNow or Jira Service Desk, it's going to integrate through that AWS Service Management connector. Explorer is your operations dashboard, which is going to be providing you with insights across your AWS accounts and regions from sources such as config, trusted advisor, compute optimizer, support cases, patching, and many more. Ops Center is our event management engine. It lets operators view and investigate operational items, which we call ops items, and then it's automatically generated from CloudWatch, config, and CloudTrail data. Then it resolves them with those automation documents. Again, also integrating with ITSM and ticketing systems like Jira and ServiceNow. Incident Manager is going to let you resolve critical application issues faster with automated response plans to declare and track the incident, notify responders, resolve with those automation documents, and provide post-incident analysis to help prevent recurrence. Change Manager is your safe and auditable change management on AWS and on-premise with pre-approved change templates to reduce business impact, automate approvals, execution and rollbacks, and provide audit details. Maintenance Window is going to let you define a schedule for when to perform potentially disruptive actions on your instances, such as patching an operating system, updating drivers, or installing software patches. Basically, it lets you define when you can make those changes. For example, if you always do your patching on Tuesday, you can designate that through maintenance windows. And then you have Change Calendar. Change Calendar lets you define a date and time range when your actions that you specify may or may not be performed in your AWS account, again, to avoid business impact. This lets you define when you cannot make those changes. For example, if you know that during your quarter financial close period, you want to make sure that no critical updates are made, no actions are made that could potentially disrupt those important business decisions. You can designate that through Change Calendar. Systems Manager's application management features help you manage and operate your application resources in a context that's really relevant to your application's teams and resource structures. Application Manager is going to help you manage applications across multiple AWS services like CloudFormation stacks, resource groups, Launch Wizard, Service Catalog, and many more. You can view operational data and alarms and take actions to go in and remediate those issues. App Config is going to let you create, manage, and deploy application configurations at runtime, automatically roll back those changes in case of errors, and toggle new application features that require a timely deployment. Parameter Store is your central store to externalize your configuration values and secrets in one location. It's organized by environment or application component hierarchies just to simplify things. And finally, Systems Manager's node management features give operators the tools that they need to perform day-to-day activities to help maintain your environment. Fleet Manager will help you manage your fleet of servers, browse file systems, monitor CPU metrics, and edit those Windows registries. Session Manager provides secure and auditable privileged access to your computer nodes for break-glass scenarios without the need for Bastion hosts, inbound firewall exception, and managing SSH keys. Inventory collects data about applications, files, network configuration, instance details, Windows registries, and roles. And then Run Command is going to let you execute controlled actions across any or all selected nodes in your fleet. Patch Manager will help you automate patching of your cloud instances as well as on-premise and edge devices. And lastly, State Manager is going to give you secure and scalable configuration management. It's going to correct configuration drift by periodically checking and remediating changes to keep your resources in your pre-configured desired state. So let's quickly discuss how you manage and register your instances so you can leverage all the features that we just mentioned, and most importantly, the features of Patch Manager that we'll discuss today. By leveraging the Systems Manager agent, known as the SSM agent, you can remotely manage any of your nodes, such as your EC2 instances, those edge devices, and even on-prem or other cloud providers. It currently supports Linux, Mac OS, Raspberry Pi, and Windows servers. And if you want, the agent is open source and it's on GitHub. So how do you actually go about registering those nodes? There's a few ways that you can register your nodes on SSM. AWS Systems Manager agent, or again, SSM agent, is pre-installed on some Amazon Machine Images, known as AMIs, that are provided by AWS. For example, when you launch an Amazon Elastic Compute Cloud, Amazon EC2, that instance that's created from an AMI with one of the previously mentioned systems, you'll likely find that the SSM agent is already installed. This can also be done via permissions and the default host management configuration, which allows instance management without the use of instance profiles and ensures that Systems Manager has permissions to manage all instances in the region and account. If the permissions provided aren't sufficient for your use case, you can also add policies to the default IAM role created by the default host management configuration. You can also gain access to public endpoints or VPC endpoints. Perfect. And now I'm going to turn it over to Anthony to dive a little bit deeper into Patch Manager.
Thanks, everyone. Nice to meet you. My name's Anthony Verlason. I am the product manager for Patch Manager, so I'm very excited to talk to you today about our AWS solution for addressing the patching need of instances that need a patch on a recurring basis. What I'm going to be talking about during this period is a little bit more about the product of Patch Manager and actually how it helps to meet that use case of patching instances securely and at scale for your EC2 and hybrid fleets. And then I'll be passing it over at the end to Eric, who will be deep diving into some of the more technical aspects about how the service works, and that will lead into some of the elements of the workshop. So I want to take a step back and talk about inventory. Inventory is another AWS Systems Manager service that's a scalable way of collecting, querying, and auditing information. So with inventory, you can gather information about instances such as resource metadata. So if you want to know instance and OS details, network configuration, or installed software, you can use inventory to collect information about those instances at scale. And secondly, you can actually collect any information you want using inventory, so it's customizable. We have some out-of-the-box items that you can collect, resource metadata that you can collect, but you can also use inventory to collect information. And what inventory will do is to collect that information at regular intervals, and you'll be able to view and browse that information. So common customer use cases of inventory is tracking application licensing usage. So if I wanted to know how many SQL 2016 MS SQL servers are we running, you could figure that out with inventory. You could also identify legacy software and applications that were installed on those instances, and you could be able to view that and understand that at scale. Lastly, you can also monitor changes over time using AWS config. So with config recording rules, there's specific config recording rules that will allow config to understand what's changing about your inventory over time. And I just took a little bit of a step back to describe inventory, which is a service that isn't Patch Manager. But the reason why this is important is because inventory is a critical building block for the entire Patch Manager use case, because we're going to use inventory to put our patch compliance information, which is basically the output of the patching service, into this place called inventory, where we can actually store and report on that information, which we'll be talking about a little bit more in the workshop. So with that, I want to get to my product and my pride, which is Patch Manager. Patch Manager is specifically designed to meet the use case of patching instances securely and at scale for your EC2 and hybrid fleet. So any instance that is an SSM managed instance, be it an EC2 instance or a hybrid or on-premises instance, Patch Manager can then take an action to patch those instances. So Patch Manager is specifically designed to give you the tools and the capabilities to actually execute patching securely and at scale, regardless of the type of environment that that instance is in, and also regardless of that operating system. So part of the value and what we try to do with Patch Manager is abstract away some of the complexities of managing the patching of those instances on a recurring basis and give you the tools and capabilities with this product to let you actually control that the way that you want. And we have an opinionated way about some best practices around that, but Patch Manager is also meant to meet the specific use cases that you might have. So Patch Manager works by automating patching by defining rules for auto approval. So effectively, we let you define what patches are applicable to an instance, which we then have a process which our service takes over and determines what patches are available. And then those patches will either be installed or not installed depending on those rules. So we let you create those rules actually per operating system, and we call those patch baselines. And I'll get into exactly what that is in a couple slides. Patch Manager also enables you to scan and install patches on a regular and recurring basis. So a scan operation basically does an analysis about what patches are applicable and available, and are they currently on that instance or not. That would be the result of a scan. Whereas an install will allow you to actually remediate that drift or determine that you want to actually install the patches that are available and applicable. The reason why this is important to have both of these functions is you might have a central team that wants to execute a central scan, but you might leave it up to the individual application teams to actually do that patching as they see fit. So we have both of these key sort of execution mechanisms in Patch Manager, and you can use these as you want as part of our service. You can schedule patching operations using maintenance windows, state manager associations, or Amazon Event Bridge. Patch Manager has basically a building block, which is a document called AWS Run Patch Baseline. And you can use that document and leverage that document in a variety of ways, some of which include these scheduling services. And as we talked about earlier and Megan discussed, and sort of the reason why patching is important is that Patch Manager is actually going to install the patches or let you understand what patches are missing that can actually help you mitigate zero-day vulnerabilities. So if there's a day zero patch that you need and there's a critical vulnerability that your security team comes up with, Patch Manager can help you actually install that patch at scale that's going to help you mitigate that risk. Another key capability of Patch Manager is the ability to understand that patch compliance to the approval rules. So over time, you're going to be more patches are going to become available by the vendors, and Patch Manager is going to let you have that view of what was available at a point in time, what was installed, and how do I currently stand against those approval rules. So we let you define those rules, and then we also let you understand how you're basically operating against that rules. And that's through a simple sort of idea of compliant and non-compliant, green or red. And you can see that widget there in the right-hand side, compliant summary. It's just a basic pie chart of green and red, good or bad. And I think another thing I mentioned before about Patch Manager is part of the value of Patch Manager is we want to let you operate at scale. We know that customers have few instances or hundreds of thousands of instances across a variety of on-prem and EC2, as well as across a variety of operating system flavors. Part of Patch Manager's objective is to abstract away all of those complexities and give you a single tool that's going to allow you to enable patching and scanning across all those instances, regardless of that OS. So you don't need to worry so much about the complexities or the nuances between those different operating systems as you execute patching securely in your fleet. So next, I want to just talk a little bit about how Patch Manager works and a little bit more about that user experience. So the first thing you really start off with is you define the approval rules for what patches are applicable and approved. So you do that through patch baselines, and that's the next slide we'll get into, but patch baselines automatically approve available patches. So what's going to happen is you're going to define when Patch Manager goes to operate on that instance, what patches are applicable, and then what patches do you approve to be installed based on what is available. And you can define those rules through the patch baseline. So that's completely flexible. We have the capability and we provide you some default patch baselines, which you can leverage. Those are based on our recommendations, but you have full control to create custom patch baselines. And we'll be talking a little bit more about that. Next is you set the schedule, so you can use an on-demand patch now operation if you need to execute a scan or a patch immediately, or you can use cron via State Manager Association or otherwise to set a schedule when you want to actually execute those scan and installs. So if you want to run a weekly scan Sunday nights at 1 a.m. or you want to run a scan every 2 weeks on Thursday afternoon, you're welcome to do that and have that flexibility with these tools. Next is you target the SSM managed instance. So as I mentioned, you can target any SSM managed instance regardless of the operating system. And we have a couple other capabilities in different places of these features where you can use different targets like key value pairs. At this point, and you've done this setup, what Patch Manager is going to basically do is execute a scan or a patch based on your rules and the setup that you did in these previous 3 steps. So Patch Manager is going to go in, determine what's available and applicable based on your rules, and it's going to execute a scan or a patch based on what you told it to do. And then it's going to return a result, which is basically your compliance or non-compliance. So we can imagine that when you want to execute an install, If a scan runs and shows that patches are missing and applicable, that would return non-compliant. But if you then executed a patch, the purpose of the patch is to make that instance compliant to the standards that you defined. So I'll be diving a little bit deeper into different features that we have for these different capabilities and how you actually do this. But I wanted to give this overview of how our service and our product actually works and what that user experience looks like. The first thing I want to talk about is really the logic and the thinking associated with Patch Manager, and this is called patch baselines. So patch baselines automatically approve available patches based on the rules you define. So you can create a patch baseline for each operating system, and even within each operating system, which products within that operating system. So for instance, you could have a different auto approval rule for Windows Server 2016 or Windows Server 2022. And you could also have a totally different set of rules for something like Amazon Linux or Red Hat Enterprise Linux, depending on what your fleet makeup is and the exact needs and requirements of your business or your security teams. So what the approval rules allow you to do is just basically determine what classification and security of patches are applicable to the instance and that you want to be approved. But we also have some other features like auto approval delays, date. You can specify a specific date that you want to provide approval for by passing that specifying the date on the right hand side of that image that you can see. Another option that we have, which isn't present in this screenshot, is the ability to specify specific patches to be included or excluded. So if for whatever instance, for whatever reason, you need to specify a specific patch you want installed or not installed for a specific reason, there are additional features in patch baselines that will enable you to do that. Another feature that we have is for Linux-based operating systems, you can specify a custom repository. So if your instances are not connected to the internet or in their own private subnets, then you can actually tell Patch Manager to reference the custom repository that that instance can point to, which gives you the added flexibility to leverage Patch Manager even in cases where you're not connected to the internet. And as I mentioned, you can define different rules for different operating systems through a consistent workflow. So the way that these approval rules work and the way these baselines work, and you can read more specifically how this logic works for each operating system, the objective is we're abstracting away some of the complexity of figuring out what patches you want to approve for installation, and we're making that a consistent user experience across operating systems. And as I mentioned, we have AWS default baseline. So if there's a little bit too much detail that I described about all the logic you can do about what patch baselines are there, and you just want to simply get started with a basic patching schedule with all the critical and security updates that we think you should have, then you can use our AWS default baselines. So next I want to get into actually what happens when we patch an instance, and I'll cover this relatively quickly, but this is really the crux of how our service and our product works. So what Patch Manager does is it applies the baselines to those instances and then it takes an action. So that action is either a scan or it's an install. So Patch Manager determines the patches available to your instance by actually looking at that instance, looking what's available on that instance, and then comparing that to your patch baseline. That's why the patch baseline is the logic of the instance, because the baseline is going to help our service determine what do you want installed or not installed, or what should be there versus what is actually there. And that's what actually occurs on that instance. So for a scan operation, Patch Manager is going to return the applicable patches. And if there are patches that are available, the instance is marked as non-compliant, which essentially means you're missing some of the patches that you approved via your baseline, and you're going to get that information so that you can decide when and how to take action. Now, you might run a scan operation on a Tuesday afternoon after or a Patch Tuesday, which is the second Tuesday of the month, and understand, okay, there was a Patch Tuesday patch that was released. However, it might not be okay with you from a business perspective or from a technical perspective to go ahead and install that patch on that Tuesday, because patching can be disruptive. You can't have a downtime. So you can use installation operation at a different schedule to actually install that patch at a time when that would be applicable and acceptable to you and your team. So what the installation is going to actually do is it's going to look at that same list of the applicable patches that were returned, and it's going to actually go ahead and install them. Just a key note here is that Patch Manager doesn't actually push patches from a central repository that AWS owns. We actually respect the repository that the instance is pointed to. So like I mentioned, you can pass in your patch baseline, point to a Linux repository that's connected to a private subnet that's not connected to the internet to get access to patches that you want to make available to that instance. And for Windows instances, this would be the equivalent of also having like an upstream WSUS server that contains those patches. So on the right, you can see a diagram. And the key note here is we have that document AWS run patch baseline, which is basically runs all that logic. And then for each instance, it's going to go on, do that logic, and then go to that repository, fetch, and either scan or install. There's a feature we have called on-demand patching, patch now, and this is just one of the features that are there on the console. This is in single account and single region. You can use a patch now operation to actually execute patches, basically as an emergency hotfix button to go ahead and install patches. Of course, you could wake up at 2 o'clock in the morning on a Sunday and install those patches if you want, but we have some other tools that are going to enable you to set that up in a more efficient manner. So performing a patch scan against a baseline or install, essentially the same exact operations are going to occur in patch now, except we have a couple other features here, which include your reboot options. So some patches, depending on the operating system, are going to require reboot for that to be installed. So we have some options like don't reboot, reboot if needed, and then schedule a reboot time. So that's going to allow you to have that flexibility to not have downtime and to basically pre-install those patches. You can control what targets you want to install, so you can specify tags or you can patch all instances in the current account and region. You can store those logs in S3 via CloudWatch logs. And lastly, you can use lifecycle hooks to run commands before, after, on exit of the patching operation. So this is going to enable you to have that added flexibility. If you need to start an application back up or take another action, then you can do that using these lifecycle hooks, which might be things you need to take action on before or after patching. So next I want to get in sort of the end of the user experience, which is understanding the result of patch compliance. So as I mentioned, when you execute a patch scanning or a patch installation operation, the result that you're going to get is either compliant or non-compliant, which indicates that either there are patches that were available and that were installed correctly, and there's no longer available and applicable patches that are not on your instance, which means you are compliant, or your instance is actually missing some of those patches that you approved. So this is generally binary. You either have the patches that are approved or you do not. And that's what the compliant and non-compliant status show. So we have a couple places where you can view this compliance information about your instances, and there'll be some things we talk about in this workshop about how to view and manage this better at scale. But we have a compliance reporting tab where you can view the results. So simply here on the right-hand side, you can see that we have some instances and their compliant status, compliant or non-compliant, as well as critical and security non-compliant count. So this is really a high-level overview of the compliant status, and then if it's not compliant, what patches are missing. That you can deep dive into exactly what the patch information is by going into Fleet Manager inventory and viewing that patch information, but we try to provide a high level view here. The output of the patching operations can be quite complex, so part of the value here is we want to abstract away some of that complexity. In this tab as well, you also notice that you can export the compliance report to S3. So if you have a reason to store this information over time and version that information, then you can also do that here from this tab, and you can store that patch compliance information over time. And like I mentioned, if you want to deep dive into patch information, you can do that using Fleet Manager inventory. So that's going to give you exactly what patches were installed and when, and what was the severity and criticality of those patches. So that's a second level detail that may or may not be required, depending on your use case. If you have to demonstrate that information to a compliance program auditor or something like that, or deep dive into those patches, then you're able to do that as well. So next I want to get into a feature that we have that we launched in January. It's called Patch Policies, and this is the way to patch across your AWS organization. So Patch Policies is actually a new quick setup configuration type, which enables you to centrally define patch scan and installation operations, and also centrally define criteria using patch baselines. So the value of Patch Policies is that from a single account, across all accounts and regions in my AWS organization, I can have a central set of baselines and rules that define what patches are applicable and what should be installed. And I can also set up a central schedule for those scan and install operations. So we're actually leveraging quick setup and AWS organizations in order to enable you to have that full cross-account, cross-region capability for patching. Part of the additional value of patch policies is that you can actually have multiple patch policies that exist at the same time. So if you have a development application or a development environment version of an application, you can set a patch policy that targets that application and development environment, and that could be something like, I want to scan the second Tuesday of the month after Patch Tuesday, and I want to install those the first Saturday after Patch Tuesday. You can do that using patch policies, and then you could have a second patch policy that go ahead and tries to install patches on the second Saturday after Patch Tuesday, which will enable you to sort of meet a custom workflow that you want to have. So patch policies are going to give you the ability to operate even more easily at scale and make it even more efficient to execute patching across accounts and regions. And the other benefit of patch policies is that you can create a patch policy in minutes using quick setup. You don't need to manage baselines across multiple accounts and regions. You can do that from that central account, and you can make it much easier to operate at scale. Another benefit is you can centrally aggregate the execution logs to an S3 bucket for debugging and troubleshooting. So if there's an issue when you go to execute that patch installation, for instance, if your instance lost connection to the internet or lost connection to a repository, then you would be able to try to debug that using your S3 bucket, which contains the logs from all the accounts and regions. And another benefit of quick setup is that we're actually also going to start automatically provisioning and managing EC2 instance profile permissions. So because Patch Manager is dependent on the SSM agent and all its associated profile permissions, we're going to use quick setup to try to make that easier for you to manage those permissions and to remediate that drift. So you can just simply worry about setting the right schedule and managing patching without having to worry too much about the complexities and issues about managing those permissions at scale. So the last slide I want to talk to before I hand it over to Eric is just give a little bit of a prelude to what you'll be working on in the workshop. But as I mentioned before in the patch compliance information, currently, you can view patch compliance information in a single account and region. We understand that's not exactly scalable. So what you'll be doing in the workshop and what I'll discuss briefly now is you can set up patch compliance across accounts and regions using AWS organizations and build a searchable and flexible dashboard that enables you to report on that patch compliance information at scale. So I'll talk a little bit about this now, but you'll be spending some time building this out in the workshop. So you can create Systems Manager resource data sinks in each account and inventory. So just to touch back a little bit about inventory, is that inventory has the patch compliance information for that specific instance, and we're actually going to use resource data sinks to aggregate all that information, that patch compliance information, into a single Amazon S3 bucket. Then we're going to take that information and create a database and tables using an AWS glue crawler so that we can get that information in the correct format that we can actually consume. And the way that we're going to consume that is we're going to query the patch or inventory data using Amazon Athena. You can use query language. And then secondly, if you wanted to visualize or build a custom dashboard, you could do that as well using Amazon QuickSight. So those are some of the things that you'll be working on today, and we'll walk you through that part of the workshop. At this point, I'd just like to conclude this section and pass it off to Eric. I hope you enjoyed learning a little bit more about Patch Manager.
All right, thank you, Anthony. So now that Anthony covered, some of the aspects of patch policies as well as reporting across the overall AWS organization, I wanted to actually take a look and go into some of the underlying architectures that put in place both of these features. So taking a look at patch policies first, this is the way, as Anthony mentioned, to establish centralized patch scanning as well as patch install operations across your AWS accounts and regions. And it all starts with the quick setup functionality of Systems Manager. So in the organization management account, you can navigate to the quick setup console and you can deploy out a patch policy. Again, you can deploy out multiple iterations of patch policies as well. So if you do need to target different accounts, different regions, or different workloads, or even different resource tags on those managed nodes, you can deploy out multiple patch policies to have that differing criteria, whether it's based off of the cron expressions that you provide for the patch scans or patch installs, or maybe just differing patch baseline criteria as well. And when you deploy out one of those patch policies, the first step is that quick setup then goes and creates a stack set over in AWS CloudFormation. Based on the parameters that you defined as far as which accounts should be targeted as well as which regions, CloudFormation then creates a stack instance in each of those target accounts. Now, within this stack instance, there are a variety of resources that are created, but for the purpose of our discussion, we're going to focus mainly on the patch scan and patch install resources. So CloudFormation creates two different associations. Again, if you are going through patch policies and you only define to put in place a patch scan, it'll only create that association. But if you do choose to perform a scan and install, it will create two associations for the document AWS Run Patch Baseline. Now, this association will target your managed nodes, whether those are EC2, on-prem, other cloud, or hybrid, and it will perform the correlating operation against it during the defined cron expression that you provided. So this will then target those managed nodes and perform either a patch scan or a patch install. So by using patch policies, we can quickly set up within a few minutes centralized patch scanning as well as patch install operations. All right, so moving on to the reporting side of things. So once we put in place patch policies or we perform a patch scan or a patch install of some sort, the target managed node will then report that information back to the local systems manager account and region. This is also true if we put in place the inventory capability and gather information about what applications are installed, networking information, driver details, and so on. And it'll report it back to the local systems manager account and region. Hopefully everyone can see my slides. Is that correct? I saw
Yes.
Glenn. Okay. All right, so once that information is reported back to that local systems manager account and region, we can then use systems manager resource data sinks to export that information into a centralized S3 bucket. Now, on the right-hand side of this diagram is that central reporting account where we have that information being placed in to that S3 bucket. So this is going to aggregate our inventory data, again, what applications are installed, networking details, drivers, and so on. And it will also synchronize the patch compliance data as well. So once we perform those patch scans or those patch installs, it'll go ahead and export that information into the S3 bucket. Now, once we have that information in that S3 bucket, these will be JSON objects, which we can then integrate with AWS Glue as well as Amazon Athena to perform SQL queries against this repository of information. By then integrating with Amazon QuickSight, we can put in place some visualization dashboards, all of which we'll take a look at in the workshop portion of today's session. The bottom right-hand corner, that QR code, it is just a link to the workshop, which we'll be taking a look at in just a moment. It's more of a reference for after the session, but we'll walk through the procedure of how to set this up during the workshop portion. All right, and then just as a quick example, as far as what we'll be building towards within the workshop portion, as far as completing that QuickSight dashboard or creating initial patch compliance dashboard, this is an example of what we can create over in QuickSight. So it's populating various different pieces of information that is hosted from that S3 bucket, such as information about the actual state of EC2 instances. Are they running? Are they stopped? Are they terminated? Where do you have your managed nodes residing across different accounts, across different regions? How many of those are compliant versus non-compliant? Then breaking it up by account and or region. And even further breaking that compliance status or non-compliant status based on the platform of the operating system. And while we talked about patch policies and that centralized patch reporting, This may be good for 70 to 80% of your overall environment where we can perform, these relatively simplistic patch operations where we just initiate a patch scan or we just initiate a patch install. Now, there may be differing scenarios where you may need to perform a little bit more multi-step or complex operations before you can actually go ahead and proceed with patching a node. So we also wanted to talk through those a little bit now. So the first one that I wanted to cover is what we call Patch Manager lifecycle hooks, or a way to orchestrate multi-step custom patch processes. So the way that this works is instead of the standard AWS Run Patch Baseline document, we can use the AWS Run Patch Baseline with hooks document, and it enables some additional functionality within Patch Manager. Specifically, this enables 3 different points where you can execute scripts or commands within the operating system of one of those target managed nodes. So the first phase is going to be prior to patching. You can perform a simple set of scripts or commands that are running within the operating system of those target managed nodes. So on the right-hand side of the screen is a screenshot that's an example of stopping the Apache service before patching takes place. The second interval is after patching takes place, but prior to rebooting, go ahead and run another set of commands or scripts. So again, on the right-hand side, the example is making updates to the Apache service. And then finally, the third hook is if you choose to include a reboot, after the instance reboots and comes back online, you can then run a final set of scripts or commands. And then again, on the right-hand side, the example is starting up Apache and verifying the application health. So some other common customer use cases are going to be around, stopping your custom web applications or databases, performing changes to the application after patching has taken place. And then after the node reboots and comes back online, validate that the application is back up and running or the database's health. And then similar to what Anthony was referring to earlier with that install override list, you may also need to perform emergency or on-demand patching across your AWS organization. So in order to perform patching on demand across your account and regions, you can leverage the Systems Manager capability automation, which we've been discussing earlier in some of our slides. This also supports delegated administration, so you can specify a delegated admin account within your overall AWS organization for Systems Manager, and then use the automation capability to target your other AWS accounts, either using organization OUIDs or the actual literal AWS account IDs as well. So by using this model, again, we can perform that on-demand or emergency patching, and you can use custom automation runbooks or even some of our predefined workflows, depending on your use case. Again, you can target using those OUIDs or the actual AWS account IDs. And then we can also leverage the install override list, which is a YAML formatted list to only install specific updates during that given patch install operation. So in these 0-day or emergency or on-demand patching scenarios, we may want to only install one specific update for a given vulnerability, whereas we don't want to install any other updates because that may affect our application's health. So you can leverage that install override list to only install that specific application, and it will temporarily override what is defined in your patch baseline. And then the final scenario that we wanted to talk about is more of a decentralized approach to patch management. Whereas with patch policies, we are pushing out these patch scans and patch install operations across our accounts and regions. And again, you can always deploy out multiple iterations of those patch policies for differing criteria, cron expressions, or even targeting. Depending on your environment, you may also want to take a look at decentralized patch management. So decentralized patch management can be enabled using AWS Service Catalog, and it allows for a little bit more customization as far as some of the aspects of performing patch install operations. Now, this may, your application teams or your account owners may require a little bit more customization around when those patch operations take place, what is the exact frequency, or you may even just providing flexibility of performing patching in those lower environments first before we go ahead and proceed with our production environments. And again, you can leverage AWS Service Catalog to actually put in place this type of decentralized patch management approach. The QR code in the bottom right-hand screen is just a link to a blog post, which provides some sample CloudFormation templates that can help put this in place. So the idea here is that while we are allowing these application teams or account owners to deploy out that service patching for their install operations, you as a central IT team can still maintain control over that patch criteria. So you can deploy out these service catalog products, which are really just CloudFormation templates on the back end, which include those patch baseline criteria that Anthony was talking about earlier. Additionally, you can push out those resource data syncs to ensure that patch compliance data is being synchronized to that central S3 bucket for reporting after the fact. So to recap what we talked about in this presentation portion of today's session, we talked about how patching can be tough. It can take time. It can introduce risk, but it's without a doubt one of the single most important actions that you can take to improving your organization's security posture. By prioritizing your patches, by understanding what workloads you have, what they run, and the importance of different types of patches have on those workloads, you can know what good looks like for your environment. You can then perform scans against your application workloads, perform checkups against them, and set up those scheduled maintenance periods using patch policies or even some of that decentralized approach that we were talking about. So by using AWS, the cloud offers that unique opportunity to get a handle on your IT assets, again, whether they are running solely on AWS or if they are hosted in on-prem or other cloud providers as well. And these simple describe calls can be used to help build that comprehensive picture of your servers and operating systems. And by leveraging automation, we can ensure that we are putting in place these scheduled operations across our accounts, across our regions, across these hybrid locations. And with that, we are going to go ahead and proceed with the workshop portion of today's session.
Thank you, Eric. Let me take over the screen. All right. You can see my screen. Let me share the URL that you need to join the workshop portion of the session. Please confirm if my voice is audible and you're able to see my screen.
Yep.
All right. Thank you. So we will be using a pre-provisioned infrastructure to do our workshop today. In order to do that, there are a few things that we need to take care of. So before you continue, make sure you log out of your business or personal AWS accounts. You have an email address that you can easily access right now. And as a workshop participant, you will have access to a pre-provisioned infrastructure with the nodes already deployed to do our workshop today. And the account will be available for the next 12 hours. So even if you're not able to follow through the workshop, you can continue on the workshop after the end. So you'll have around 10 more hours to continue your workshop. And also this is a public workshop. Even if you're not able to complete within the 12 hours, you can go back to the workshop and try it out on your personal or business account. Please make sure that you understand the terms and conditions of the event. Do not upload any personal or confidential information during the workshop. So we'll be using our workshop studio to do the hands-on lab. You can reach the workshop using the URL I already posted in the chat. If not, you can scan or type in the URL. So once you are on the Workshop Studio page, you need to sign up. Choose one of the sign up methods. And the 12-digit event access code for today's workshop is on the screen. I'll copy that in the chat as well.
I already pasted that on the chat, by the way.
Thank you.
You're welcome.
And I'll also paste the one-time easy link if you want to directly go into the workshop. Paste the one-time,
Yeah, you
one-click
can.
URL.
Okay, you did. Perfect. Thank you.
Thanks, Maroon. So once you join the workshop, you will see the join event screen. You can review and join the event. From here, I'll switch to my browser. Let me swap my screen share. All right, now we'll see my browser screen share. So I'm on the page where I'm reviewing and joining. So click on join event. Agree the terms and conditions and join the event.
Hey, Deepak,
You
can
will.
you zoom in?
Oh, okay. Maybe I'll share it on the big screen. Oh, maybe it's better.
The right side looks good, yes. Might need to zoom on the left side too.
Okay. Yeah.
Perfect, thanks.
All right. So once you join the workshop event, you will be on this landing page. You can click on to access the AWS console. You can click on the link on the left-hand side bottom and takes you to a new tab. And you'll be on the console homepage. So as part of the workshop, we will be covering a couple of sections from the overall workshop. One is the patch management section, and the other section is the advanced workshops. So as time permits, we will be able to cover the all the chapters within advanced workshop, if not the first chapter. So I'll begin with the patch management. As you have listened to the expert talking about the patch management feature of Systems Manager. In order to continue with the patch management, the foundational block is setting up a patch baseline, which is the auto approval rules you want to do based on the platform type of the managed node. Um, I'll just show you quickly the necessary managed nodes to continue the workshop is already provisioned for you, which you can see in the EC2 Management Console. From the console homepage, search for either Systems Manager. If you cannot already see it in the, because I have visited it, it's stored as a recently visited item. If not, you can search at the search bar for Systems Manager, open up a new tab.
I think we'll need to zoom in on the right-hand
Zoom
side
in.
as well.
Sure. All right. So as part of the patch management section, so we'll be doing a few things. One is first we'll do a scan of our EC2 instances for missing updates. We will install any missing updates on the EC2 instances. We will also show you how to schedule a patch for both scanning and install operation. And finally, we'll look at how to do a report on the patch compliance across AWS accounts and regions, and also how to visualize that data or the reports. Because in Workshop Studio, we are limited to a single account and single region. We may not be able to show you the organizational level steps, but you can follow the workshop in your own business or personal account with the AWS organizations. So once you are on the Systems Manager homepage, um, if you're not able to find the navigation pane, you will find the 3 lines at the left side. Expand the menu and navigate to Patch Manager. On the Patch Manager homepage, because you're the first time we are visiting it, you have to click on Start with an Overview. So first we're going to set up 2 patch baselines, one for Amazon Linux 2 and another for Windows. To do that, I head to the Patch Baseline tab and click on Create Patch Baseline. So as you can follow from the workshop steps, you can copy the name of the patch baseline. I'll use the copy option. Similarly, copy the description and make sure you change the operating system to Amazon Linux 2. For the Amazon Linux 2 patch baseline, we'll set up a couple of rules. So to begin with, the first rule, we'll keep the products as all. Under classification, let's select security and bug fix. For severity of the patches, we'll choose critical and important. In terms of how many days, after how many number of days you want the patch to be installed, we'll keep it as 2 weeks. It's 14 days. For compliance reporting, you can select critical, or we'll leave the optional include non-security updates in the first rule, but let's set up a second rule for non-security update patches. So in rule 2, we'll leave it for all products. We'll leave the classification and severity in terms of approval, approve patches after a specific number of days. Let's change that to 7. And compliance, choose it as medium. And here, let's select this box to install non-security patches that meet the approval rules. For Linux operating platform, you have the option to choose the patch repository source. If you can set up to 20 custom patch repositories. So we'll leave the patch exception and sources as default, and click on Create Patch Baseline. You'll see the patch baseline request comes succeeded. You can check the details.
Hello. I hate to interrupt. I was wondering. My name is Jesus Rodriguez. Just calling out of Entertainment Benefits Group. I was wondering, how about when I want product classification and severity, and I wanted to patch it all? I want to do a full DNF or Yum update, and I want to update all every time for this patch baseline. How do we go about doing that? I noticed that you only selected security and bug fixes.
Yep. So if you want to just install any updates, so in that patch baseline criteria, we would just go through and either just select star, you can select all, or you can just add, the explicit severities and classifications. So what Debon was showing was, he is specifically including those security and bug fix, but you can optionally just change those classifications just to include all of them, as well as that non-security update flag.
Yeah, that answers the question.
Yeah, so basically I'm under product all, classification will be all, severity will be all. And wouldn't you have to also approve patches to include non-security updates on the bottom? Previous screen you were at in the baseline. Um, uh,
Yeah, yeah, that's right. You mean here, right?
right.
Yeah.
Okay. Yeah. Is that just maybe you'll answer some of the rest other questions because that's what I did and it doesn't seem to work. Maybe I missed something else, but we'll
Okay,
see.
maybe we can try and chat
Yeah,
and chime and see if we're able to provide some more guidance.
Yeah, no
sure.
problem. Sorry for interruption.
Yeah,
No problem.
thanks. All right. So now we have set up the Linux platform uh, patch baseline. Let's set up a Windows patch baseline. And to do that, head back to the Patch Manager, Patch Baseline tab, click on Create Patch Baseline. Um, Similarly, copy from the workshop the name of the patch baseline, copy the description, and the operating system is already chosen as Windows. We leave it as that. In terms of approval rules, we'll have only one rule for the Windows patch baseline. It's for all products. Under classification, we'll choose critical updates and security updates. In terms of severity, you choose critical and important. Approval rules, we will leave it as 0. So as soon as the patches are available, we will apply to our managed nodes. In terms of compliance reporting, we'll choose that as critical. You can optionally you can tag the rule or the patch baseline. We will do that in the workshop and just click on create patch baseline. Oops. And you can view the details. The patch baseline is set up with the one rule. So once we have set up the patch baseline, in order to make them the default patch baseline for the platform, we have to use our CLI command to do that. To continue with the workshop, you can either open the Cloud Shell in a separate tab, or if you click on it, it will open right in your screen, working screen. I'll expand it to show you. Let me see if I can zoom this. All right, okay. So copy the command from our workshop to find out what are all the default patch baseline for Linux and Windows platform. I'll paste it, acknowledge the warning, and paste. You will see it lists all the patch baseline for Linux and Windows. And you notice that for Windows, this is the default patch baseline. And notice the two patch baselines that we created are the default flag is set to false. Here, set to false. So this is the baselines we created in the previous section. So we're going to change that now. To exit the command, click on Q. To register a patch baseline, we'll use the command register default patch baseline command. I'll copy that over. You need the baseline ID. I'll copy the baseline ID from here. All right. So we have registered our Linux patch baseline as a default. I'll do the same for the Windows. So go up, clear the baseline name, patch baseline name, and copy the Windows baseline ID. All right, now we have made both the Linux and Windows patch baseline that we created as the default patch baseline. We can confirm that by rerunning the command we ran initially. Go to the bottom of the command. You can see now our Windows is the default, the baseline that we created is the default. Similarly, the Linux that we created is now the default patch baseline for Linux. So once you're done, you can end the command and you can close the Cloud Shell. Yeah, you can exit it. Cloud Shell. I'll zoom in. So we are end of the chapter 1. So we have created two new patch baselines for Amazon Linux 2 and Windows. Now we'll go to the next chapter, which is scanning the managed nodes. So in order to scan or manage nodes, we're going to use the document called AWS Run Patch Baseline. As you know, Systems Manager document contains the actions that you want the Systems Manager to perform on your managed nodes. To find the AWS Run Patch Baseline document, you can head to the document homepage. If your navigation is closed, expand the navigation and head to Shared Resources and Documents. You'll be on the Documents homepage. You can search for the document name if you know. So I'll just hit search for patch. And you can see the different documents with the patch name on it. We are interested in the AWS Run Patch Baseline document. This is a pre-configured document offered by Amazon. There are more than 100 pre-configured documents that you can use. If there is a functionality that you want to enhance an existing document, you can clone the document and update to do the functionality that you need or remove the functionality that's already there. So we are interested in to run this patch baseline. All documents have parameters for the AWS run patch baseline document. The mandatory parameter is the operation. You have to say whether you want to do scan or install operation. The rest of the parameters are optional. So I'm going to use this document to scan our manage node to find the nodes that are missing the patches. So let's click on run command. Again, run command is one of the features of Systems Manager capability. This allows you to run or execute commands across multiple nodes instead of manually logging into each of the nodes. Using run command, you can send commands to nodes across regions or based on tag. We are on the run command landing page. We are using the run patch baseline document. We leave the defaults in terms of operation because we are interested in scanning our managed nodes. We leave the operation as scan. In terms of targets, we'll use the specify instant tags from the workshop. Again, you can copy the tag. These are specific, so make sure you match the case and click on add. So we're going to search for all the managed nodes with the tag, workload, and value of COM workshop, and scan those nodes to see if they are missing patches. So rest of the run command, it's optional. You can say when you want a timeout. In terms of rate control, do you want to see if you want to set up how many targets you want to start with, or when you want the execution to stop based on the number of errors or the percentage. I'll leave the default for this part of the workshop. And we are not writing anything into S3 bucket, but if you want, you can capture the logs into an S3 bucket. Also the other optional CloudWatch alarm and SS notification, we are not doing it in the workshop, but you can. If you want to run this same command from a command line, this is the command, but we'll use our console option run. So once you are set up, let's click on run. And we'll wait for some time and refresh. And you can see our run command is targeting 8 of our managed nodes with the tag as workshop and COM workshop's value. You can see the status. Give it a few minutes. You can refresh to see which node's completed. We can go and check on the node that's completed the execution by clicking on the instance ID. And based on the type of the platform, so the node that I clicked, let's see if it's Windows. Yeah, it's not a Windows node. Let's check if it's a Linux. Yep, it's a Linux node, so you can see it executed the scan operation on the node. You can find the operation type as scan. So I'll head back to the command, and yep, all the 8 nodes are scanned and it's completed. Let's yeah, so in this section, we scanned our managed node to see which are the nodes that are missing patches. So once you're done with the chapter, click on next and head to the third chapter, which is reviewing the patch compliance and install missing patches. So to review patch compliance, you head back to the system. If you're on the Systems Manager page, expand the navigation pane and go to Patch Manager. And within Patch Manager, head to the Compliance Reporting tab. And you can see the 8 nodes that were scanned in the previous operation. So of all the of the 4 nodes, of the 8 nodes, 8 managed nodes, like 4 are compliant and 4 are not compliant. And you can see why node is not compliant. You can click on the missing patches. So if you click on the number on the right, let's see the state. Yeah. So this node is missing 2 Windows patches. And this is a Linux node, so you can see all the packages that are missing. So once we have reviewed what are the nodes that are missing or not compliant, we are going to install those patches. So in order to do that, again, we are going to use the run command and to do that for us. So head back to run command, again under the navigation pane. Under node management, you'll find run command. Click on run command and search for the document name if you already know. If not, I'm searching for patch, and you'll see a document called AWS Run Patch Baseline. So I have selected the document. In the the previous chapter, we were doing only scan, but this time we are going to install the missing patches. So we swap the operation to install. We leave the other options as default. In terms of the nodes to target, we'll continue with we'll use the same option as specify instant tags and copy the option and the workshop content. So I'll leave the patch and the value as true. Make sure you add the tag. If you miss this, you may not see the targets. In terms of rate control for this workshop, part of the chapter, we will choose the concurrency to 10 targets. So to target 10 nodes at a time, and also change the error equal to 10. I'll disable we're not writing in the output to S3 bucket. I'll leave the default for CloudWatch Alarm and SNS. If you want to do the same thing from command line, you can copy this and execute from the command line, but we'll use the UI option and click on run. Again, give it a moment and you can refresh to see. This time it's targeting only 4 nodes. As you noticed in the patch manager screen, there were only 4 nodes that were non-compliant. Or not based on the compliance. So we are targeting based on the tags. So it goes and checks the nodes which has the tag patch with the value true. So I'll just quickly show as the command executes. If I click on any of the node and check its tags, not all the nodes have the patch key and value. So let's check on the other node. Let's see if it has. Yeah. So only those nodes which has the tag patch with the value true are being targeted. That's why we see only 4 nodes in this execution. So let's keep refresh and see. It's pending with 2 others. Let's check on the details for the one that's completed. Click on the output. It looks like this is a Windows node. That's why the patch Windows step is completed. And you can see what are the patches that are installed. And this one looks like although it's targeted for install, it's not missing any patch. So we don't see any patch getting installed. Head back to the command history and refresh. We'll wait for these 2 nodes to complete. All right, all the 4 nodes are complete. So we'll look on a Linux node. You'll head to the patch Linux tab and see. It looks like this is also not missing. Oh, let's look at the output. It has installed all these patches. All right. So now let's go back to our patch manager screen and see what nodes got patched. I'll close this and head to patch manager. So you can go to navigation, patch manager, and compliance reporting. Refresh this. Yeah, as you can note in the workshop content node section, 4 nodes, 4 managed nodes like Windows non-comp 1, non-comp 2, and Amazon Linux non-comp and non-comp 2 are intentionally missed out for patching. So that's why you don't see them as compliant. You can see the rest of the nodes are patched now. So 4 nodes have been intentionally left as not for install. Sorry. All right. So now we have seen the couple of options. One is first to how to scan a managed node for missing patches, and we also seen how to install the missing patches using the AWS run patch baseline run command document. So with that, we complete chapter 3 and click on next. And so far, you have seen that the way we have scanned or installed the missing patches is through a document, and it's a manual operation. If you want to automate this patching operation and across multiple accounts and multiple regions which belong to an AWS organization, you can use patch policies. So that's the focus of our next chapter. So we're going to show you how to schedule the patch using patch policies. So head to patch manager and as Anthony told during his presentation that the patch policy feature was launched in December last year or January this year. So click on create patch policy. It takes you to the AWS quick setup landing page of Systems Manager. And because we are doing this quick setup for the first time, you have to click on Get Started, and you have to choose a region where you want to do this quick setup. This workshop is based on the US East 1 account, so let's keep the default and click on Get Started. So for the patch policy, we'll input a patch policy name. I'll copy the name from the workshop content. For this patch operation, we are going to choose scan and install. So we are going to schedule this scan and install. You can choose a scanning schedule. Either you can use the default, which is 1 a.m. UTC daily, or a custom schedule. We're going to use the default scanning schedule. For installation, we choose a custom, and you can choose the frequency either daily or using a cron expression. We are going to use a cron option and copy the cron command from the workshop content. This is targeting a Saturday, so every week Saturday at 11:30 p.m. UTC. We will ensure that this checkmark is selected, so we will wait for the install updates until the cron interval. Otherwise, as soon as you create this patch policy, all the nodes will go through the install and scan and install operation. But we want this operation to be run only on Saturdays. So let's keep that enabled. You can optionally reboot. So I will leave the default, which is unselected. And again, for patch baselines, you can go with the defaults, which is based on the platform type. What is the current default patch baseline? The system can choose, or you can select the patch baseline that you want to use for installing the missing patches. For our workshop, we will change the patch baseline for Linux to Amazon Linux 2 to custom, which we have already created or provisioned as part of the workshop setup. Similarly, for Windows, we'll change it to the, instead of the default, we change it to the custom patch baseline. And you can see the supported operating systems that Patch Manager supports here. In terms of patching log storage, again, we are not using it, so let's disable the option. In terms of target, so this screen can change whether you are running this from an account under an AWS organization. Because for the workshop, we are limited to a single account and single region. We don't see the organizations option here. But if you're running from an organizational account, the screen will differ, and you'll have option to choose either the entire organization or a particular organizational unit. But for the workshop, we are using the current region. And for the nodes, we're going to use specify node tag and add our key value pair, which is workshop, workload, and value as com workshop. In terms of rate control, we change that value to 50. For error, we do the same. So we are going to target 50% of the node every time we execute. And once that's complete, it goes to the next 50. And similarly for error, if there are 50% of node that failed an execution or patching operation, the patch policy will fail. For instance profile, let's check this option or enable this option. And you can review the patch policy settings here. Once you're okay, then go ahead and create the patch policy. All right, this will take a few minutes for the patch policy quick setup to complete. We'll give it some time. So behind the screen, behind the scenes, the quick setup is using CloudFormation templates. So you can review that if you go to the CloudFormation console. You will be able to see that stack sets that this quick setup is using. You can check the screenshot. Scroll down. You can click on a quick setup configuration and check the details. And you notice that the AWS quick setup scan operation is failing. This is due to how the workshop is set up, due to insufficient permissions. You will see the notes in the workshop content, but in real world, this should work. Let's see if the configuration, the quick setup configuration is completed. All right, so it says success. In order to, because the scan update failed or scan association failed, let's go and rerun that association. To do that, head to go to Systems Manager navigation pane and go to State Manager. And you'll notice all the association that the quick setup has created. And one of the association is for the scan operation. And you see it here. If I scroll to the right, you see it says failed. We will click on the association. You can see the details, like what are the resources that it tried to do the association or run the association. It failed on the 8 managed nodes we have. To reapply the association, let's click on apply association now. Say apply. We go back here, says it's pending. You also notice that the install patch association is also in the pending state. That's because it's waiting for the cron. So it will not execute right away. It will execute on Saturday as we chose a cron schedule. So you can go and check the execution history. So this is the execution. You can see already 2 nodes success, pending with 6. Let's click on the execution and you can check the output. Maybe it's too soon. Let me refresh and try. History, click on the execution. Let's try the output for one of the successful nodes. Yep, you can see the output. And if it's not a Windows node, it looks like a Linux. Let's check it out. Yep. And you can see the operation type as scan. So let's head back to the association. We have one more node to finish. All right, so the scan is completed now, and you can see it's a successful occur on the 8 managed nodes. So that's how you use patch policy to schedule your scanning and install operation, patch operation. We are at the end of the chapter, and as discussed during the presentation, that you can use the patch lifecycle hooks to do your pre-patching or post-patching steps. So if you want to execute some activities before you start a patch or after you've finished a patch, you can use the lifecycle hooks. Right. We are at the end of the chapter in under patch management section. So far, we have seen how to scan our managed nodes and install the missing patches. Um, if you're managing multiple accounts across multiple regions, you can use our patch compilation reports that Eric talked about during the presentation time. So we will show you how to set up for a single region, single account. To do that, so we'll be using the fleet manager, resource data sync, the inventory feature of the systems manager, which collects metadata about the managed nodes, and also a couple of other tools to go and query your patch compliance data. So you can see if I head to fleet manager, under account management. So these are the 8 nodes or 8 managed nodes we have. Under account management, if you click on resource data syncs, there is a resource data sync that's already set up for us by the workshop provisioning. And you can see where our inventories are collected. The inventory data is stored in a S3 bucket. You can click on the S3 bucket and open a new tab and investigate the contents of the bucket. I'll zoom in. Yeah. So if I click on the inventory bucket, you see there are only 6 objects as noted in the workshop notes. Or in the screenshot, you see there are 14 objects. In order to get the rest of the inventory data, we had to do a little detour. To do the detour, like follow the notes on the workshop content, which says configure EC2 instance using host management quick setup configuration. I'm going to click on that, and it takes you to this page. So let's complete this section in order to get the full inventory data that we need to do the rest of the workshop. So let's go and follow the steps under this section, which is configuring the EC2 instance using host management quick setup. Let's go and follow the steps. So go to the management console, your systems manager homepage. I'll go back to systems manager homepage, click on quick setup. Because we have used the quick setup already, you may not see the get started screen, and you will see the landing page with the patch manager configuration already completed. So we'll go directly to the create option and choose the host management configuration. So what this configuration does is it adds IAM role that is required for, or gives the permissions for the systems manager to manage your nodes. If they miss the particular role, it will add that role to the node, and also starts collecting inventory from that node. You can also enable whether you want to scan that instance or the new nodes for missing patches. So we will ensure to keep the first 2 options selected, and we don't want to scan, which we have already shown you how to do using other options like the run command and patch policy. We will leave the rest of the options as not selected. In terms of target, again, we are limited to the current region. And for nodes, I'm going to let's use the tag option and copy the key value pair from the workshop content. Say workload and com workshop. And yeah, once the options are selected, let's go ahead and create the host management configuration. This will take a few minutes. So what it does is, as we discussed, it goes and checks for nodes which are missing the IAM permissions for the systems manager to manage a node. And if I go back to the instances, you notice that we have provisioned 10 nodes, and we used only the 8 nodes in the previous sections of the workshop, or previous parts of the workshop. But after this host management configuration completes, it will include the 2 nodes which were missing the role um, to be managed by Systems Manager. So we'll show you in a moment. All right, the configuration is complete. You can check the details, the configuration. So what are the associations it ran? All right, let's head back to close that. If I go back to Patch Manager or Fleet Manager, you'll see I think the nodes are still restarting, so we'll give it some time. Again, there's a note in uh, the workshop that says if your nodes are not showing up in the Fleet Manager after 3 minutes, you may have to reboot those EC2 instances. So I'll wait to see if we see 2 new nodes. If not, I'll do a quick restart or reboot. Okay. Still shows only 8 nodes. So let's go ahead and restart these 2 nodes or reboot. So I'll go to action, reboot the instances. All right. Yep. Now our managed nodes increased to number 10. You can see app 1 and app 2 are showing up in Fleet Manager after the reboot. So we have completed the host management step. Let's head back to our report section under patch management. And now if I head back to the S3 bucket under inventory, you see that now we got all the 14 objects that we are looking for. So yeah, you have to complete that host management step if you want to see the 14 objects that required to continue with our workshop. So what if you want to drill down to the inventory data, the metadata that's been collected, let's pick one of the object, let's say instance detail information. If you click on that as shown in the navigation here, you click on bucket, plugin, account number. So account number, then you click on region, then the resource type. We have selected the managed instance inventory, and you notice that all the 10 nodes metadata has been collected and stored as a JSON object. In order to report on this JSON data, which is in S3 bucket, we will use the AWS Glue to convert these JSON data into tables that we can query. Again, to do that, go to the AWS Glue console. So I'll head back to our management's the home page. You can search for Glue and click on AWS Glue. Open in a new tab. I'll open that. And once you're on the Glue page, you may have to expand this data catalog, and under crawlers, we have already set up a Glue crawler for you. It's called the SSM Glue crawler. You can click on the crawler and see the details that it runs midnight every day, or start of the day. So because it runs only at the midnight, we want to run it now. So click on choose run crawler, or you can do that from here. Select this and click run. So what it does is it goes and reads the data from our S3 bucket and converts those JSON inventory objects into tables. We'll wait for the crawler to complete and investigate the tables to make sure we get the table data that we can query on. This will take a couple of minutes. And again, as noted in the note section or the caution section, you can see if you've missed the host management step, you will only see 6 tables because there were only 6 objects in the bucket. So if you complete the host management step, you will see the full 14 objects. Right, let's head to the table section and see how many. Yep, you can see it has created the 14 tables and still refreshing them. So I'll keep 1 more minute and I'll head to the Athena section. Okay, the crawler completed the job. So all the tables are created, which we can confirm from here. In order to query this table data, we'll use our query tool, Athena. To use Athena, again, you can search from the search bar, search for Athena, and click on Athena. And because it's the first time, let's launch a query editor. Once you are on the Athena homepage, make sure you change the work group to COM workshop and acknowledge the warning. We can close the banners. We have already set up some queries, the Athena queries that we're going to use as part of the workshop provisioning. So you'll notice that there are 7 saved queries. You can run any of these I'll show a couple of examples. Let's use this query patch summary query. And you click on that and you'll see the predefined query. It goes and search for all the nodes with the tag workload and com workshop and gives you the patch summary information. So let's click on run. And you notice it completed and shows you the information about all your managed nodes and how many patches are missing on each of those nodes, and how many are critical, how many are non-critical. You can see the lot of information. What was the baseline that's used to compare? You can go back to saved queries and execute one more. Let's find out the instance list or SSM agent. Let's find out what is the SSM agent version on each of the managed nodes. You can see the different versions on the different managed nodes. Yeah, you can continue to execute all the queries. Um, so in this chapter, we saw how to see the data that's collected as part of the inventory in S3 and how to use Athena to query those data. And you can create reports from this tables. And as you see in Athena, these reports are all like numbers. If you want to visualize this data and present it as a dashboard, that's where we use Amazon QuickSight. And that's our next part of the workshop. Hope you were able to follow me till this part. With that, we have completed the patch management section. We now head to the advanced workshop. And within that, we're going to show you how to create a dashboard um, and find all the patch compliance information across your AWS organization under multiple accounts and multiple regions. And again, as I said earlier, because this workshop content is limited to a single region, single account, whatever action we do, you can perform that under multiple accounts or multiple regions. But for the workshop, we will be limited to a single account. All right, let's head to advanced workshop.
Hello. Hello.
Yeah,
Sorry.
hey, hello.
Yeah, sorry to interrupt you. So is it possible to get that node's IP or that host name over here in this table?
Yeah, you can collect all the information. I have to check whether the instance information has that inventory data, but you can customize it. Hey, with that, let's head to the section 2. To do that, there are some prerequisites that need to do. If you're directly starting this chapter or section, because we have already scanned our instances, we have completed running the group crawler, we have the data in the tables, the glue tables, we are good to skip this prerequisites and head to setting up AWS QuickSight account. So to do that, I'm heading to console and search for QuickSight. On QuickSight, you have to sign up for a QuickSight account. So I'll say sign up and let me zoom. And for the workshop, we are going to use the standard edition. To check, select the standard edition, you have to come to the bottom of the page where it says sign up for standard edition here. So click on here. And let's fill those details. So you have a couple of options for the authentication method. We will go with the default, which is using both IAM federated identities and QuickSight managed users. In terms of region, we will leave it as the US East, where this workshop account is based. For the account info, you have to make sure this is a unique QuickSight account name. So I'm going to copy from the workshop and just add some random numbers. And you can use a email address. So I'm going to use some user account. If you want to receive the notification, you have to use your working email address. For the services that QuickSight we need to integrate, we just need the Amazon Athena. So we are good to deselect Redshift, RDS, and IAM, and choose Finish. So that completes the setting up of the QuickSight account. So once that's done, click on go to Amazon QuickSight. So before we start creating the visuals, we need to set up some data sets. So we need 3 data sets to build our visuals. So in the workshop, we cover the steps to create those data sets. We'll begin with setting up the first data set, which is the AWS instance information. So once you're on the QuickSight homepage, click on go to the datasets section and choose a new data set. We have chosen only Athena as our service that we want to integrate. Let's choose the Athena as the data source. Under the data source name, let's enter the name that's on the content. And in terms of work group, choose the COM work group and create the data source. From the list of databases, select the SSM Global Resourcing, which is selected for us by default. And under the list of tables, let's select the AWS instance information and select and click on choose the directly query your data option. And click on edit or preview data. So once you're on this page, we are good here. So just say, click on save and publish at the right-hand side top. So once the dataset is saved, you can close the warning, the message, and cancel the visualization page. So we created the first dataset. Let's create the 2 more datasets. So to do that, repeat the same steps like go to datasets, new dataset, choose Athena as the data source. In terms of data source name, copy the name from the workshop, or you can choose some unique names. choose a COM work group, and click on create data source. And this time from the list of tables, choose AWS compliance summary. I'm not sure if I can, okay, yeah. Zoom in. Choose AWS compliance summary and select. Choose the directly query your data and click on edit or preview data. In this view, we want to do a few more steps. So before you publish, in the top right, you see add data. Let's click on add data. And from there, choose the data set. And we'll choose the data set that we created in the previous step, which is AWS instance information. Select that. We are going to create a join. So click on this dots. This determines the type of join you want to use. And we'll leave the default, which is a left join. And in terms of the fields to match, for the compliance summary, choose resource ID. And for instance information, choose instance ID. Make sure you apply the join. And once you are done, now we can, all right, we also have to update the dataset name. So here, if you click on the name of the dataset, you'll be able to edit it, copy the name from the workshop content. So I updated the name. Now you do save and publish. All right, so we have created 2 datasets now and 1 more to go. So click on new dataset, choose Athena. Let's give it a name. I'm copying it from the content. Choose the work group, create a data source. So we're going to repeat the steps that we did in the earlier section, in the previous section. But for the table, we are going to use the AWS compliance item. Select, do directly query your data, then click on editor preview data. We'll add another data set to do the join, and this time we'll use the same data set we used in the previous section, which is AWS instance information. Select that, choose the type of join. We leave it as the left join. In terms of the fields to match, we'll do the resource ID to instance ID, apply the join, and save and publish. Oops, sorry, I had to change the name. That's too fast. Yeah, do not forget to update the dataset name. Once update, let's publish it again. All right. So now we have 3 data sets. You can see here, one is the AWS instance information, joined compliance summary with the instance info, and the third one, joined compliance item instance info. So once we have these 3 data sets, we are done with this part of the chapter, which is creating data sets in QuickSight. Click on next. Now we are going to use these data sets to set up our visuals. All right, to do that, all right, before visuals, we will do the analysis, then to the visuals. So in the steps, let's head to the analysis section, choose new analysis. And we can choose the data sets that you want in our analysis. choose AWS instance information and click on use in analysis. We'll leave the new sheet default as interactive sheet. Sorry, I may be fast here. Yeah, okay, create. And under the dataset, you see the pencil icon here. Click on the datasets and add the two other datasets that we created. So which is the joint compliance summary, select that. And do one more, repeat the step for joined compliance item instance info. So once we have the three data sets added to the analysis, close this window. Now you should be able to see from the data sets, we'll be using these three data sets to create our visuals or in the analysis. That completes this chapter. Then let's go to the section where we're going to create the QuickSight visuals and the dashboard. So we will begin with the first graph that we are going to set up as the instance count by status. So once you are on the analysis page, choose visualize or like select the graph, and you can select the visual types you want to use. Let me see if I can zoom them. Yeah, all right. For the visual types, I'm going to choose donut chart. And for the fields, let's drag and drop. So for instance ID into the value field and instance status to the group field. In order to count the distinct instance, let's change the aggregate from count to count distinct. And, we can see the 10 nodes or the 10 managed nodes we saw in the earlier section. So once the instance count is changed, let's go ahead and set up a filter. So here we're gonna add, click on add filter, choose instance status, and click on that filter, and you can choose apply to all applicable visuals and choose apply. And if you choose the filter, the three dots to the side of the filter name, you have an option to do pin to top. Let's do that. So you'll see that filter pin to the top of the analysis. And also let's change the name of the filter. Click on edit and change the name of the filter to instant status equals, and click outside the name and you should see it reflects the name of the filter. And let's select the graph. We want to edit the title. So if you look at the top right corner of the graph, you'll see a pencil icon. It says format visual. Click on format visual, click on title, edit title, and copy the title name from the workshop, or you can name your graph. Save the title, head to legend, and disable show legend, and expand data labels, and choose enable this show metric and value only. Change the font size to large. So we set up. So once you're done, you're good with the format. So we completed the first graph. Scroll to the left. So we have complete setting up the first graph, which is count of easy to instances by easy to instance state. Because all our instances are running, it shows as active. But if you have some instance in stopped or termination status, you'll see a difference as shown in the workshop content. So next graph, we are going to set up instances by account ID. To do that, we are going to duplicate our existing visual again on the menu option that's available for a graph. You can click on the three dots and select duplicate visual. So it duplicates the visual that we already created. We're going to make some updates to this visual. For the field wells, we're going to change the group by. Instead of instance status, let's change it to account ID. So if I select the group and you can choose account ID, go to the filter page and you click on add filter, select account ID and select the account ID filter. You do the, excuse me, and apply it to all applicable visuals and click on apply. And also you do the, click on the three dots to the side of the filter name and pin it to top. And let's rename the filter. Oops, yeah. Let's rename the filter as in the filter name in the content. Once you're done, let's change some of the visual properties. To do that, format the visual. The title, change that to instance count by account ID. The title. You are done with the second graph.
Hey, Debon, I'm not sure if your microphone moved, but it's very quiet.
Sorry, yeah. Is it audible now?
Yep, sounds good. Thanks.
Okay. Yeah, so we have created the two visuals. Let's set up the third one, which is the instance count by region. So we're going to repeat some of the steps from the earlier, which is to duplicate the visual. Let's do that, duplicate the visual. This time, go to the fields. And instead of the account ID, let's change that to region. Head to filter, add a third filter called with the region as a field. Select the filter, apply to all the applicable visuals. Click on apply. Once done, click on the three dots and pin it to the top. So you can see it's added to the other two filters that we have. Expand the filter and let's rename this filter as well. This time we change that to region equals. And because this is a visual based on the region, let's change the title. So to do that, go to the visual menu and click on Format Visual. Click on Title or Expand Title, Edit Title. We just say Instance Count by Region instead of Account ID. Save that. Again, because we are limited to single account, you will see only like one region. But if you have multiple regions, you will have an option to choose them in the filters. Instead of all, here you'll see the other regions are similarly for accounts, multiple accounts. All right, we set up the 3 instance related visuals. Let's go to the 4th graph, which is looking at the patch compliance status. So to do that, we have to change the data set that we're going to use for that visual. So from the AWS instance information, let's select the joined compliance summary instance info. Once you select the data set, click on visualize, add and visual. You'll see the add sign here. So click on add and add and visual. So it adds a new empty graph page. So let's start with the type of the graph you want to set up. Let's go with the donut chart for the fields. Let's choose status as the group. So either you can drag and drop or yeah, for the first time you have to do it, sorry. Oops, let me remove that to the group. Oops. Remove that. Oh, so why is it not working? Okay, let me first drag the instance ID into the value field. Okay. Not sure what's going on. Let me refresh. I'm wondering why it defaults to let me remove this visual and see if I can run on a new one. Visual donut. Okay. Status. Okay. So additionally, we're going to add a few more drill down for the group. Let's add account ID. region, resource ID. All right, for drill rounds, status, account ID, region, and resource ID. Then drag and drop the instance ID to the value field. Again, in order to do the distinct, let's do a distinct count and go to the filter. Let's add a filter called for the field compliance type. Click on the filter. And for the search values, deselect all and choose only patch and click on apply. Okay, and for the graph, so you can see now it shows the number of compliant instances and non-compliant instances. Let's format this visual. Click on the pencil icon in the visual, edit the title because it's a new visual. It's there's no title, so let's say patch compliance status by managed instance count. Expand the donut chart and disable show labels. Expand the legend and disable show legend. Expand the data labels and click on show metric and font size to large. So now we have the graph that shows the patch compliance status by the managed instance counts. So we're done with this visual. Let's create the next visual, which is patch compliance by patch operation type. So I have 10 more minutes before I hand it over to wrap up the workshop or the session. So let's try to complete this visual, then I'll hand it over to Eric. And you can continue to work on these visuals after the work, after this today's presentation, as you have 10 more hours. So let's make sure the data set, go to visualize, make sure it's under the joint compliance summary instance info. Once it's there, go add and visual. In terms of for the filter, add a filter. Let's for this visual we use execution type. Expand the filter. For search values, we deselect all and choose only patch policy and apply. And choose visualize. Select the horizontal bar chart for this visual. Let's add the fields. For the y-axis, choose instance ID. For the value, choose sorry, this is the execution type. And instance ID to the value. And status to the group. And for the aggregate, choose instance count distinct. And let's format this visual as well. Let's click on the pencil icon and choose format, edit title. We'll copy the title, patch operation type, save the title, expand OE axis. For the label size, change it to large, expand data labels, and choose show data labels. And we are done with this visual. So if I close this, you can see what is the execution type, and we have 8 non-compliant and 2 compliant visuals. We have 6 more minutes, so I will continue with the creation of the next visual. This time we are doing patch compliance by platform type. Again, let's make sure the dataset is joint compliance summary. You can verify that if you expand, not this. Summary, go to add a visual. In the filter, select add filter, and for this visual, we use compliance type. Expand this. You can select only the patch. And in terms of apply to, select all applicable visuals, and let's apply this filter. Choose visualize. We'll go with a donut chart. Choose platform type as the group. Platform type and instance ID to value. Let's change the aggregate to count distinct. Again, let's select a filter and add status. For the status of this visual, let's deselect and only select compliant and apply. So only there are 2 nodes which are compliant, and both are Windows. Select the graph. We can update its title. Let's click on edit title, copy the title name, workshop, compliant instances by platform, expand the legend, disable it, disable show legend, expand data labels, and enable show metrics. For value only, choose for the metric label style, choose value only, and the font as large. Yeah, once you're done with this, we're going to duplicate this visual. So to duplicate, click on the 3 dots, duplicate visual, and select the filter, choose the status. And this time change it to non-compliant and apply. And you can see for the non-compliant instances, there are 2 Windows platform, and the rest of them are Linux. So, yeah, let's change the title for this one. To change the title, click on the format visual pencil icon, go to title, edit title. This one is non-compliant, so just add non-compliant instances by platform, save the title, and you are done. So if I zoom out, you can see there is a compliant instances by platform. There are only 2 compliant instances and both are Windows. But for non-compliant instances, you can see there are 2 platform types. A couple of them are Windows and 6 of them are Linux. So we have top 10 missing patches. Hey, Eric, I want to do a quick time check. Do you want to continue creating the visual or?
Yeah, sure.
Okay. So I'll continue with setting up the top 10 missing patches.
Oh,
Visual.
sorry. I thought you meant pass it over. Yeah.
Oh, okay. All right. Yeah. So yeah, I'll now hand it over to Eric. You can continue with the workshop, setting up the rest of the visuals as we are running out of time. We have to wrap the session. But you can follow the steps from the workshop and continue to set you the rest of the visuals. I will just, before I wrap, I'll just show you once you are ready with the visuals, the way to publish that as a dashboard is we go here and click on share. So let me quickly zoom. Yeah, you see the share option and you can click on publish dashboard. You can name your dashboard and publish the dashboard. So once you publish, you can send the dashboard link and you will see all your visuals. You can play around with QuickSight. There are so many other functionalities that I couldn't cover in the workshop, but you see where we are going.
La.
All right. Hey, Eric,
So
you
to
can
say
take over. Thank you, everyone, for listening to the hands-on workshop. I'll now hand it over to Eric.
Awesome. Thank you. All right. So just to give another glimpse as far as what the end dashboard would look like. So I'm just sharing out my screen here. Hopefully you can see it all. Let me just make it a little bit bigger. There we go. So hopefully you should be able to see the screen again. This is what we were talking about during the presentation portion of today's session. So including information about where these non-compliant or compliant managed nodes reside, as well as some information about what are those updates that are actually marked as missing. Breaking it out by account, region, and then listing out those details. Just to show another example of a QuickSight dashboard that you can create, because QuickSight is fully customizable. The information that you want to populate on your dashboard is entirely up to you. So this is another version of a patch compliance dashboard. Again, providing a lot of the same similar information that we were taking a look at from the workshop dashboard. But probably just some of the widgets that differ here mainly is just a count of those updates that are missing based on their overall severity for some of those managed instances. All right, so at this time, we'll go ahead and just open it up to Q&A. We have about 15 minutes left now. So if you do have any questions, you'll feel free to post them in the chat again. And then we can go ahead and proceed from there. 2 other quick things before I start going into the questions. I did post again the PDF of these slides today, so feel free to open that up. Hopefully it works for everyone. And then I also pasted a link for a survey for today's session. Please take some time to fill out the survey. This will help us improve future events and maintain a high bar of consistency and value for everyone attending. All right, so Jason asks a question. Can Systems Manager detect missing tags and or add them based on what is scanned from the instance? For example, an instance with Apache has detected it, so it should receive a tag from Systems Manager. So in that type of scenario, what I would say is that Systems Manager can detect what applications are installed. You may want to use the service AWS config. The reason that I mentioned that is AWS config can ingest that information from Systems Manager, identifying that an application is installed. And in that case, we can use config as that, I guess it would be a little bit more of a compliance scenario. So it may depend on your exact use case. But config can be used for some automatic remediation as far as resource tagging. I think we might need to talk through that one a little bit further, Jason.
Okay.
But config may be an option. I think it's just going to be dependent on maybe how many of those different types of taggings you might expect.
Yeah, I think what I would like to happen is since there's so many different things running in the company, I would like tagging to sort of be that source of truth of how we decide to manage the different aspects of things, whether it's the size of an instance, the kind of monitoring that it receives, the alerting monitoring thresholds, etc. And so if I could have a management system or configuration management program that has the ability to scan an instance, see that it's either missing specific tags or adding tags based on the information that it scanned, I can then use maybe hooks or something to look at that tag and then accordingly apply whatever policies or compliance or patching that I specify.
Yeah, so if there's explicitly a base set of tags that should exist, config does have a rule to evaluate that type of information. So like the example in here is all EC2 instances should have a cost center tag. But for some of those more dynamic scenarios, I think we would potentially look towards more of an event-driven model using like EventBridge and some of that inventory information. Automation, these automation runbooks, they can attach tags. I think there actually might be one. But I think
some of these runbooks can attach tags.
Yep. Yeah, so these automation runbooks, they can just make AWS API calls, or you can include Python or PowerShell scripts that in turn use Boto3 or PowerShell to make those API calls to AWS to attach those tags.
Okay. Yeah, I would like to talk further on this if you have the ability. That'd be great.
Sure.
Thanks. Appreciate it.
All right. So there was another question from Kevin. Is there a way for instances to drain from a target group or ALB so they can be patched without potentially affecting production? So depending on which is the use case. So if we're talking about auto scaling groups, there is a automation runbook called, let's find it, patch ASG instance. I'll copy this link, as well as patch load balancer instance. So depending on the use case, whether it's for an auto scaling group or if it's for a instance that's behind a load balancer, we do have these two automation runbooks that are available from AWS that you can go ahead and leverage for those two types of scenarios. All right, all right, let's see the next question. So from Aravind, is there a timeline for when delegated admin will be supported? So unfortunately, we can't talk about roadmap, but I would recommend getting in contact with your account team, and then we can share roadmap details under NDA. Apologies for that. Thanks, Alex, for the feedback on the survey. We'll take a note for that. And from Michael, what's the best way to handle resource that may have been terminated or offline? How do administrators accurately report on these resources? So as long as a managed instance, or sorry, let me back up. As long as an EC2 instance is checking in with Systems Manager and you have this resource data sync functionality configured, the information will be dropped into that S3 bucket within that JSON file. So let me, oops, sorry, I think I'm messing up my, I think I might have a filter on here, but let me go to Athena real quick instead. So over in Athena, which is really, querying that JSON file in that S3 bucket, one of the properties in the instance information table is called instance status. So this is the exact status of that EC2. So in this case, my EC2 instances are up and running. If they were stopped or terminated, they would reflect that same status here. And then as far as tying it within that patch compliance aspect as well, when we run these queries, let me see if I can just run one real quick. And when we run our patch compliance queries, or even the information that we populate over in QuickSight, it will include information about when the last data was captured. So when the last patch operation, whether the scan or install was performed. So we could join those two tables, to see, is an EC2 instance in a stop state? Okay, when was the data last captured for it? To maybe extrapolate as far as whether or not we expect that resource to still be non-compliant when it starts back up. All right, so Alex asks, what's the best way to stay current with AWS Systems Manager changes or features? I've been using it and noticed there's some new features that were not there last year. AWS blog. So that is, I'll paste the link for our cloud operations blog channel. So this will cover all of the AWS cloud operations, again, kind of going back to what Megan was mentioning at the beginning, kind of covering that entire breadth of services. One other location that I would recommend is going to be over actually in the user guide. Let me pull that up real quick. Okay, so over in the user guide for Systems Manager, there is a topic at the bottom called document history. So when there are, new topics or maybe changes to the overall user guide flow, sometimes our tech writers kind of reorganize things for better searchability. They will also populate this table with a new entry. So for example, Ops Center, we recently added or enabled a configuration within Quick Setup to allow for multi-account Ops Center aggregation. So they'll include an entry here, and then you can always see the corresponding topic. You can also add this to your RSS feed. That's what I personally do in order to help keep myself up to date with Systems Manager and receive those notifications. All right, any other questions? Okay, if there's no other questions at this time, thanks again, everyone, for taking the time today to attend today's session. Again, please fill out the survey, take a little bit of time just to fill that out so we can continually improve and look forward to hosting more of these events in the future as well.